All right. A meatball leaves the edge of a table with a purely horizontal velocity of 1.35 meters per second and lands a horizontal distance from the base of the table, right? You got to understand that that's horizontal. I feel like we know this, and we know this, and this. We always know that, and this, and because it's a cliff problem, we know this. That's what I think we know. Okay, so let's see. So 0.694, that's how far horizontally we land, 0. All right, the 1.35 are these guys. This guy's 0, this is negative 9.81. And then that's 0, right? Okay, I think the way this is going to play out, I think we're going to solve this horizontal side first, right? So S is UT, right? So 0.694 is equal to 1.35 times the time. So okay, I can just divide, right? So 0.694 divided by, that gives us the time. So the time is 0.51407. And that, of course, you can fill in the other side too, right? All right. And now we just do what we do, right? So S is UT plus 1/2 AT squared, right? So S is going to be 1/2 negative 9.81. The U is 0, correct? Okay, times 0.514. Don't forget to square that. Okay, so 0.5 times negative 9.81 times that answer that I just got squared. I get negative 1.2962. All right, and to find the final velocity, important stuff here. V is U plus AT. So 0 plus negative 9.81 times 0.51407. So negative 9.81 times that 0.514 answer that I got before. And that's negative 5.043. I'll say 431. It's negative 5.043066666 meters per second, right? Okay, so we filled in everything. Let's see what we can answer, right? So how high is the table? We're going to use this to answer that question, right? To get from the top down, right? Remember the problem is the meatball goes and lands on the floor, right? To get from the top down, we had to go down about 1.30 meters. That means the table is 1.30 meters tall. I'm just taking this number and rounding it, right? It doesn't make sense to say that a table has a negative height, so I'm making it positive. And then what time does it take the meatball to hit the ground? I'm going to use this. That's our time, right? 0.514 seconds, right? And then what is the speed of impact, right? To find the speed, I've just got to take this final velocity vector and find the magnitude of it. That's just the hypotenuse. So this looks like this. Now I could do everything. I could find the angle and everything like that. But all I have to do is find the hypotenuse of the velocity vector, right? So the magnitude, the speed, we'll do that here. Use space. So the speed is the magnitude, is the square root of 1.35 plus 5.0431 squared. Let's see if I can do that. Square root of 1.35 squared plus, I got to put this in parentheses, that guy. I'm using the up arrow on my calculator. I'm getting 5.22. Right? Now I know you could find any of these angles and all that stuff, right? But remember the speed is just the magnitude of this vector. Okay, so when they say speed, they're talking about the hypotenuse of the velocity vector. Okay? Yeah.